we're going to continue our study of rational exponents. We're being asked to simplify. Simplify 25 to the 1/2. Well, we know this means the same thing as the square root of 25. So, to simplify this, it would simplify down to just 5. In the second one, we have the 64 to the 1/3. Well, that means the cube root of 64. And the cube root of 64 is just 4. Finally, we have the 256 to the 1/4, which means the 4th root of 256, and that is also just 4. So we can simplify these in a pretty straightforward manner. Why don't you try these? Now, these look to be really similar, but they're actually all different. Here we have negative 64 all to the 1/3 power. Well, that means the same thing as the cube root of negative 64. And the cube root of negative 64 is just negative 4. The second one is different, although you happen to get the same result. This means negative 1 times 64 to the 1/3. The fact that it's not in parentheses really does matter. So this means the same thing as negative 1 times the cube root of 64. And since the cube root of 64 is 4, this will also end up being negative 4, but for a different reason. In the last one, we have 64 to the negative 1/3. So we need to remember that a negative in a negative exponent is telling us to take the reciprocal of the base. Now that we've taken the reciprocal, the exponent is positive. This means the cube root of 1 over the cube root of 64. The cube root of 1 is just 1, the cube root of 64 is just 4, so this simplifies to 1/4. Let's look at a different idea. In these three problems, we're being asked to write them in exponential form. So in the first, we have the square root of y cubed. Well, our base is y. So one way to write this would be as y cubed to the 1/2 power. But by power to a power, this is just y to the 3/2 power. And here's the connection we really want you to make. Notice that the index 2 is related to our denominator in our exponent, and the numerator 3 is related to the power inside the square root. In the second problem, we have the cube root of x squared. Well, if what I just pointed out is true, this would be x. The denominator would be 3, the numerator would be 2. So it would be x to the 2/3. And the last one, the 4th root of z cubed. Well, the numerator would be 3, and the denominator would be 4. If we wanted to generalize this a little bit, if we have anything, we'll say x to the let me back this up. If we have the bth root of x to the a power, that can always be interpreted as x to the a over b. These two things mean the same thing. Why don't you practice one of these before we get out of there? Go ahead and translate these three into exponential form. If you did the first one correctly, you should have gotten x to the 5/2 power. And the second one would be z to the 3/4. And the last one would be y to the 2/5. The denominator of the exponent and the index are identical. The numerator of the exponent is the power on the base number.